Okay, we did a 5-1 to 5-3 quiz. Here are the solutions to it. This is in pre-calculus. I always say change everything to sines and cosines. Tangent is sine over cosine. Because they're squared, it's squared. Divided by secant, which is 1 over cosine. Now, I notice this is all true, but I'm trying to make it into a subtraction. I don't believe this is going to help me to do that. So maybe I can do it in a more direct manner. Do we know the Pythagorean theorems, that identity, that 1 plus tangent squared equals secant squared? If I subtracted 1, what could I call tangent squared? Secant squared minus 1. So this could be called secant squared minus 1 on top. They're both divided by secant. They're both divided by secant. So secant squared divided by secant is secant. 1 over secant is cosine. So now it should match what we want it to match. Okay, number 2, we want to identify or verify this identity. To add or subtract fractions, you need a common denominator. You can always get a common denominator by simply multiplying your two denominators. So what do I need on the left? I believe I need a cosine. Cosine times cosine is cosine squared. On the right, I need a 1 minus sine. 1 minus sine. I can't tell you how many people put this. That's not correct. If it's 1 minus sine and it's quantity squared, you square the first. Yes, you square the last, but I think you're totally neglecting the twice the product in the middle. So I don't think it's just 1 minus sine squared. It should be 1 minus 2 sine x plus sine squared. Now, I have sine squared plus cosine squared. That is 1. Plus this one is 2, which now allows me to factor a 2 out of the top. If I take a 2 out of the top, you'd have 1 minus sine, which could cancel with the 1 minus sine on the bottom, leaving me 2 over cosine. We're using x's. 2 over cosine, which is 2 times secant. Hopefully that now matches. After 2, we have 3. We have to find an identity that matches this. Cosine A, cosine B. Opposite, sine A, sine B. And this thing should equal cosine of A minus B. Why is it 50 minus 5 and not 50 plus 5? Because one of those is on our trig table, the other is not. 55 degrees is not on our trig table. 45 degrees is, and the cosine and sine of it would be radical 2 over 2. Now, sine of 105, we have to make an axis, realize that 105 is bigger than 90, but less than 180. How much less than 180 is 105? 105. I don't think I could do it that way, so I'd have to write it some other way, right? Can I write it as a sum of two angles that I know? How about the sine of 60 plus 45? Does that add to 105? Do I know the identity for sine? Well, I think it's sine cosine, the same thing, and then reverse cosine 60, sine of 45. This is radical 2 over 2 for the 45 degrees. Cosine of 60 is 1/2, which means sine of 60 is radical 3 over 2. Top times top, bottom times bottom, top times top, bottom times bottom. Now that you have a common denominator, you could write it as radical 6 plus radical 2, the whole thing over 4. We're going to move on to 5. This is a tangent. We just need to know if it's tangent plus or tangent minus. There is a rule, if you can find it on your note card, that says tangent A minus tangent B all over 1 plus tangent A times tangent B. And I believe this is equal to the minus, isn't it? A minus B, am I wrong? So this would be the tangent of, what's A? Pi over 5 minus, what's B? Pi over 30. So pi over 5 is 6/30 minus 1/30 leaves me 5/30. 5 over 30 simplifies to 1 over 6. And I think I know this trig value, or this value, from my trig table. Okay, after 5, we're going to move to 6. Some people, I was glad, I'll be honest, some people realized that the cofunction identity says that that's equal. That wasn't really what I wanted, because what we're supposed to do is use the cosine of A minus B. That would be cosine A cosine B plus sine A sine B. So let's fill these in. This would be cosine cosine plus sine sine. And what's A? A is x. What's B? Pi over 2. When you looked at pi over 2 on the unit circle, its coordinates are 0, 1, cosine, sine. So what's the cosine of pi over 2? So you have cosine of x times 0, which is 0. Anything times 0 is 0. Where we have the sine of x times, what is the sine of pi over 2? 1. And 1 times sine is sine. So that's more what I was looking for, more than the cofunction identity. I really wanted you to verify the cofunction identity. On to 7. Sine squared of x. This is probably the easiest approach. Sine squared of x plus, does anybody know an identity for cosine of 2x? And what happens with sine squared minus sine squared? They should cancel, leaving me with simply cosine squared, which is kind of what I was trying to show. An alternate approach might be to call sine squared 1 minus cosine squared. And then you'd have to change this into what? Cosine squared, or actually you could call it what? There's 3 different ones for cosine of 2x. Do you recall them? No, there's 2 sine squared. Cosine squared could be 2 cosine squared minus 1. 1 and a negative 1 would add to 0. Negative 1 cosine squared plus 2 cosine squared would be 1 cosine squared. So there are alternate approaches. Let's look at the last one, number 8. Do we know an identity for 1 minus 2 sine squared of theta? Was this going to be cosine of 2 theta? I believe that was the same, well, we had it on this one right here, right? So what would theta be? pi over 12. 2 times 1/12 is 1/6. So this could be cosine of pi over 6, which I think is radical 3 over 2. I hope these help. Good luck.